In this video, we'll discuss the PCA model using UnifyML SQL. Principal Component Analysis, PCA, is used to reduce the number of features while retaining most of the data variance. Now, let's see how to apply the Spark PCA model using UnifyML. Start by mentioning the input table and selecting the required input columns. The number of reductions parameter specifies how many features to retain, and you need to set an integer value. If you want to use the PCA model in other Spark functions, you can save the model for future use. Additional input arguments are available, which you can find in the UnifyML documentation. The input data types parameter allows changing column data types. You can also split the dataset into training and test sets by specifying the training sample size, with the remaining data used for testing. The number partitions parameter defines the number of partitions and specifies the column for partitioning. Data cleaning options include removing rows, removing duplicates, removing outliers, and filling missing values. If you need to fill null or missing values, use the Fill with Values parameter. For data scaling, four methods are available: min-max scaler, standard scaler, normalizer, and binarizer. If using min-max scaler, specify the minimum and maximum values. If your data is already stored in the cache, use the input cache ID instead of the input table name. The bytes per chunk parameter defines processing size. These are the input arguments for the Spark PCA model. Set the parameters based on your data and requirements, then run the query. This query executes in the backend of the UnifyML server. The output includes input columns, the number of reductions applied, and the saved PCA model name. You can now use this PCA model in any Spark function with the input table. By following this method, you can apply the Spark PCA model to reduce the number of features efficiently. Thank you for watching this video.